Okay, in this video, I'd like to show you a few different interesting and useful sets of numbers. I kind of showed you one a little bit for a short period in the other videos, but these are very famous numbers. They're useful. These are the sets of numbers I said would pop up at strange places, but regularly do pop up. They are in the Pythagorean, Pascal's triangle. They're this set or this set. Missed it. And then they are called the triangular numbers because if you can arrange them into triangles, equilateral triangles. So here's a triangle with no side lengths, 1 dot. Here's a triangle with sides of length 1, and you can do that with 3 dots. A triangle with sides of length 2, you can do that with 1, 2, 3, 6 dots. So you can see that there's 1, 2, 3. This shape has 3 more dots than this shape. This shape has 2 more dots than this shape. The next one will have 4 more dots than the one before it. So you add 2, you add 3, you add 4, but you make equilateral triangles and you count the dots in them, and you get this sequence of numbers which are referred to as the triangular numbers, because you can shape them into triangles if you have that many objects, equilateral triangles. But they're also useful not just because triangles are nice, but because it represents summing the counting numbers. So what's 1? Well, it's 1. What's 1 plus 2? It's 3. What's 1 plus 2 plus 3? It's 6. What's 1 plus 2 plus 3 plus 4? It's 10. So the triangular numbers, when you're adding another layer to the triangle, you're really just adding the next counting number to the sum. So this sequence of numbers also represents the sums of the first n counting numbers. So the sum of the first 2 counting numbers is 3. The sum of the first 3 counting numbers is 6. The sum of the first 4 counting numbers is 10. So it's not only nice for making triangles, it's nice for summing up all the numbers from 1 to whatever number. And there's a formula for this, so you don't have to actually add all these up. There's a formula. So I want to explain the formula in this video, where it comes from, and in the next video I'll show you, I'll use it for something. Just before we go into those, that's the main topic, is the triangular numbers. I do want to show you a couple of other sets of numbers. I'm not going to use them right now, but I'd like you to just be aware of them. And there's formulas for those as well. You can look them up. These are the square numbers because you can make squares. Nice, nice, nice. The thing to notice about them is you're not adding 2 and then 3 and then 4 and then 5. You're adding 3 and then you're adding, so you added these 3 to the 1 before. Then to that box you're adding 5 dots. And to those boxes you're adding 7 dots. So this is actually the sum of the odd numbers. So this is the sum of the counting numbers. These numbers represent the sum of the odd numbers. In addition, they also represent the numbers that you can arrange into a square. There's the pentagonal and the hexagonal numbers. So, and they're different. Here's another picture that's kind of shows, what you had before. 1, add 3 for another square. You have 4. Add 5 for another square. And you have 9. And you're adding the evens, and you're getting these squares. Those represent the sum of the evens. The square numbers do. For adding I'm sorry, adding the odds. I should have said odds. I'm getting ahead of myself. That was adding the odds. So add 3, add 5, add 7, add 9, and a 9. It's a 5 by 5, so there's 25. And if you add up 1 plus 3 plus 5 plus 7 plus 9, you should get 25. If you're adding the even numbers, you would have, it's this pattern. So 1, you don't do 1 because you want the evens. But 2, you see these side ones that aren't marked with numbers? Add to 2, 4. So you got those two orange ones, but now you have these green ones here. So now you've got this little triangle and this little triangle. So 2 plus 4 is 6. Add 6, these ones, and now you've got this little triangle. And these little triangles, you've got 2 of them, like 2 little lobes. So it's times 2, but it's the counting numbers. So it's similar to the counting number formula. But we're not going to go into those. I mean, you can sort of visualize them as shapes. You can, they're interesting too. There are formulas for those too. But we're just going to look at the triangular numbers because they represent summing the counting numbers. I hope you're following this. And again, they're in the triangle. All right. So I just wanted to explain what the formula is and how you can sort of see it. Here's the triangular numbers up to 3. So there's 6 of them. You could arrange it like this. And when I have that, if I duplicate it and flip it, you see I got the 2 colors. It doesn't make a square. It makes a rectangle. The way I've done it. I could have put these here, but it's the same dimensions of the rectangle, however you do it. So to figure out what the sum is for 1 or 2 or 3, well, the triangle will be half of this rectangle in this case. So the dimensions of the rectangle will have to be the number that you're going up to, 3, times, the area of a triangle, base times height divided by 2. So 3, 4, that's 12, divided by 2, that's 6. So the sum of the first 3 numbers is 6. And this formula will always work. Take the number, add 1 to it, multiply those, and then have it. There's also, so that'll make the, that makes the formula. So if you want the first 10 numbers, 1 plus 2 plus 3 plus 4 plus 5 plus 6, you want up to 10. We did that in the previous videos. We got 385. Well, can I pop up my little calculator? Yeah, there it is. So, well, 10 times 11 divided by 2, 55. Well, that should be the sum of 1. Oh, we did the squares. So 1 squared plus 2 squared plus 3 squared. I was like, well, this isn't right. So let me do the other one really quickly. Whoops. No, I better edit that. Where did I go with that? Here we go. Looks like I closed Wolfram Alpha. So sum I for I from 1 to 10. 55. So close that. Well, we used the formula. We just said 10 times 11 divided by 2. Let's just sum up the first 10 numbers. If I want the sum of the first 100 numbers, so 1 plus 2 plus 3 plus 4 all the way up to 100, 50-50. Let me pull up my calculator again. And up to 100. So I'd take 100 times 1, divide by 2, 50-50. So that's the nice formula for summing up a range of numbers. Actually, I guess I'll just do both videos on this one since I've kind of already got into it. Where am I now? Okay, so that's the formula. If you want to go up to 5, well, 5 times 6 divided by 2, 15. If you want to go up to 20, 20 times 21 divided by 2 is, what, 210? So you can figure out what the sum of the numbers are up to a certain number quickly and easily with a formula. These are really nice in math competitions, but they do pop up if you're doing kind of math problems. They were coming up in some of the problems I gave you in those problems that I wanted you to work on. So here I'm writing it as a function, the triangular numbers, as a function of the number you want to go up to. You could express that function in summation notation, so summing the k's from 1 to n. That would make, 1 plus 2 plus 3 up to n. There's another justification for it. So for instance, if I wanted to, so you can visualize and justify the formula from the triangle formula. If you make the rectangle by duplicating it and then halving to get the triangle. You can also justify the formula, like if I, let's say you've got this, well, 4 plus 1, the outer ones, make 5. The next ones in also make 5. Every pair, if you take a top and bottom, it'll always add up to the middle. Well, double the middle actually. It'll always, well, it'll always be one more than the last number. So 4 plus 1 is 5. 3 plus 2 is 5. So you got 5. How many times do you have 5? Well, you're making pairs. So it's for half the numbers that you have. So if you have 4 numbers, you'll have 2 pairs. So for the total number divided by 2, n divided by 2, that's how many pairs you have. The pairs will add to the number plus 1, 5. So there's another way that you can justify the formula by making strategic pairs. And that justifies the formula. So that's the formula. And it's good. So if you wanted a particular triangular number, that's all you would do. So I'll probably put a quiz up where it says, what's the sum of the numbers 1 to 20? And you'll say 210, because you'll do 20 times 21 divided by 2. 20 divided by 2 is 10. 10 times 21 is 210. So you can do that. It's just this formula. But we also said in a previous video, I don't know if I still have it up. Well, I said that if you sum from 1 to a number, well, what if you didn't want to go from 1 up to a certain number? What if you wanted to start at a higher number? So 10 up to n. Well, that's going to be the same as 1 up to n. So the sum from 10 up to n. So if I said, what's the sum of the numbers from 10 to 50, inclusive, counting 10 and counting 50? So 10 plus 11 plus 12 plus 13, all the way up to 50. What's the sum of that? Well, the way to do that, we have a formula for 1 up to a number, but not 10 up to a number. So the way you can do that is by combining the formula with what you know about sums. 1 up to a number is the same as 10 up to a number if you subtract from it 1 up to 9. So if I subtract, crap, so if I go from 1 up to 9, and what's that? 9 times 10 divided by 2. So 9 times 5, that's 45. So if I do the formula 1 up to n minus 1 up to 9, that'll be the same as 10 up to n. Because this one will do 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9. This will do 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11 plus 12 all the way up to n. But then I'll subtract the 1 up to 9. So I'm really only left with the 10 plus 11 plus 12 up to n, which is this. So if you're asked, what's the sum of 10 to 50? Well, what's 1 to 50? That's 25 times 51. I'll do the calculator in a second. And then you'll subtract, that's 1 up to 50. Then subtract 1 up to 9. And what will be left is 10 up to 50. I hope that makes some sense. So we'll do it by calc. So this 1 up to n, we know, is, I'm going to replace this. I'm replacing this first sum, 1 up to n, using the formula. It'll be, let me see if I can make a fraction. So fraction, it'll be n times n plus 1 all over 2. So for whatever n is, and I'm going to subtract the fraction, 9 over 9 plus 1 over 2. So which is 9 plus 1 is 10. So knowing the sum of 1 up to n from the formula, just take n times the number bigger divided by 2. The sum of 1 up to 9 is 9 times the number bigger up to 2. The difference between those is 10 to n, the sum. So if I say that n is 50, oops. So from 10 to 50, then I would put 50 in for n. So 50 times 51 over 2. So using the formula and realizing that I can subtract the sums, I can get a sum with different, not from 1 to something, but from anything to something else. So I'm going to try to do that. How do I clear? Okay, so 50 times 51 divided by 2 is 1275. Minus 9 times 10 divided by 2. So that should have subtracted 45, and it did. So now I'm at 1230. So I used the formulas there. Just to double check that, I'm going to go to the sum of I, for I from 10 to 50. And the formulas worked. So that's just what I wanted to show you, that you can write these sums. You can use software to calculate the sequences and the sums if you want. There's a set of numbers called the triangular numbers that actually, to do the triangular numbers, there's a formula, n times n plus 1 over 2. That'll give you 1 up to n. And if you want some other number up to n, you can just subtract 1 to the number minus 1 less than the lower index, 1 up to the 1 less than the lower index. So you can count, what's the sum of 1 to 100? What's the sum of 50 to 100? You can do both those things using the triangular numbers and just doing it twice, paying attention to the indices and the limits of the indices, and subtracting those. So I hope that all makes sense. Let me know if it doesn't. Have a good day.